Alright, so here's another example from the homework in Chapter 9, Test for Mean, for a single mean. This one has data in it, okay? So the average number of cavities the 30-year-old Americans have in their lifetime is 7. Do 20-year-olds have a different number of cavities? The data showed the result of a survey of 16 20-year-olds who were asked how many cavities they had. Assume that the distribution of the population is normal. Okay, so this is the raw data. What can be concluded at the 0.10 level of significance? Right, so for this study, we should use a t-test. Right, we have raw data. It's n is less than 30, right? N equals 16. We don't know the population standard deviation, so then we use a t-test. Okay. So my null hypothesis is that the mean is equal to 7, and the alternate hypothesis, it says do 20-year-olds have a different number? So it's not going more or less, it's just different. So mu is not equal to 7. Alright, so now we need to do the calculations. So first with StatCrunch. Alright, so you have to type in the data in one of the columns. I did that ahead of time, so I don't waste time doing that. So you got to take your data from here and just type it into a column. Right, and then you go to stat and t statistics with one sample with data. Okay, and you're going to choose the column name of R1. Then you're going to type in your hypothesis. So the null is that mu is equal to 7, and the alternate is mu is not equal to 7. And we're going to compute. Right, so we get this information here. Okay, so that gives us the t-statistic and the p-value. Yeah, so we have our t-statistic, 2.573. And our p-value is 0.0212. All right. Okay, before we draw a conclusion, let me show you how to do it in calculator. So let me quit this. So you go to, well, you have to input the data first. So we're going to go to Stat and Edit. And we need to put in the numbers in list 1. So if you do if it's full already, if you do the arrow up and you do clear and enter, then clears the list. Okay, so we're going to type these numbers in. So we're going to do 10 and 8. Now I'm going to pause it so you don't have to watch me type in. There you go. I typed in all the values, and you can see the last line says L116. That means there's 16 values in there. Alright, so now I'm going to go to second and mode to quit that screen, to get out of the table. Go back to stat and now scroll over to tests. And we're going to do a t-test like we decided. Alright, so now this t-test, we have the input as data. So we're going to use the arrow to hit the data. Alright. And the mu0 is the mean from your hypothesis test, which was 7. This tells you what list to use in your data table, which was L1. Then we need to choose the alternate hypothesis. So mu is different. So we're going to choose that one. All right, scroll down and calculate. Okay, so we have the t-value 2.573, the p-value 0.02119 or 212. All right, good. This also gives you the mean and standard deviation, which is nice. StatCrunch does that too. So you basically, if you're looking at if you need to know the mean, it gives it to you. All right, so let's see. Now we need some conclusions. Okay, so let's look at comparing the p-value with the alpha value. So alpha was 0.1, so p-value is definitely smaller. Okay, so the p-value is smaller than the alpha value. This means we reject the null hypothesis. Okay, rejecting the null means that there's enough evidence to support, statistical evidence to support the alternate hypothesis that the mean is different than 7. Okay, so we're going to say not significant, so that's not true. Not significant, that's not true. The data suggests that the population mean is significantly different from 7 at that level of significance. All right, so that's what we choose. All right, now interpret the p-value. So p-value gives you the probability in the tails. So let me put up StatCrunch. Okay, so when I was doing the StatCrunch, I chose the p-value plot. That's a useful thing to show. Okay, so if you scroll here, you can see the p-value plot. All right, so the p-value of 0.0212, this is the probability in these tails right here. Okay, so so the t-stat, the 2.5733, means that you are kind of about 2.6 standard deviations from the mean on one side and on the other. All right, and the p-value is the combined probability in these tails. All right, so what's it saying? All right, so the one we choose is going to be this one. So if the population mean number of cavities for 20-year-olds is 7, and if you survey another 16 20-year-olds, then there will be a 2.119%, which is the p-value, chance that the sample mean for these 16-year-olds would either be 6.13 or greater than 8. So in our p-value plot, so the mean was, so the mean was 7.875. And the t-statistic was 2.573, so that many standard deviation on either side. Okay, all right. All right, so that's what the p-value. The p-value gives the probability of these occurrences. Okay. All right, so interpret the level of significance in the context of the study. All right, so if the population mean number of cavities is 7, if you survey another 16-year-olds, there will be a 10% chance that we would end up falsely concluding that the mean number is different from 7. All right, this is not it. All right. Alright, that's the one. Actually, this is the one. It has like one word different between these two. So if the population mean number of cavities for 20-year-olds is 7, and if you survey another 16 20-year-olds, then there will be a 10% chance that we will end up falsely concluding that the population mean number of cavities is different. So that is like the 10% error that your conclusion is incorrect. All right, so there it is.